This is the first problem. The 1A part states that interpret the estimated regression coefficient of age in the concept of this study. So estimated regression coefficient of age is negative 0.08061 and the intercept is this thing over here 5.05706. Comparing this with the y is equal to beta 1 plus beta 1 x, we can write this as equal to, first you need to write the intercept, that is 5.05707 plus, actually it is negative 0.08061 times x. So this would be your regression line equation. Y is equal to this intercept negative times this is the coefficient of age times the x age. So here this x is age as you can see, and the y is the shear strength. So these are the two and this age is called the independent variable and shear strength is called the dependent variable, that is the y and the x. The question asks you to interpret the slope. So to interpret the slope, this is the interpretation we just wrote. For every increase of 1 unit of age, like as this increase, this change this to 1 unit, like if this is increasing by 1 unit, then the change in the shear strength would be 0.08061. It is negative, hence the shear strength would decrease. So this is how you would write the interpretation of the regression coefficient of age, and it is also known by the name the slope. So regression coefficient of age or this independent variable is known as the slope. So every time this kind of thing is given, you say that like interpretation is given for every increase of 1 unit of this x, whatever this is, for every increase of 1 unit of x, the y, here in this case shear strength, would increase by this much. Here it is negative, so you will say decrease. Positive, you will say increase by this much amount. That's how you would interpret the slope, this thing over here. This is beta 1, also known as the slope. So here in this part B, it is asking you test the hypothesis that the slope is 0 versus the slope is negative. So this is what we are going to test. So in this test, the test statistic, the t is that this is the test statistic. I'll write it. The t value you can say. So this is equal to the beta 1 upon SE, the standard error of slope. The standard error of, okay, so beta 1 here is, as you know, it is equal to the slope is negative 0.08061. You can see it very clearly from here. And the next thing is the standard error of slope. So the standard error of the slope is is given as 0.01474. So if you do the division, like 0.0861, let me do that, 0.08061 divided by 0.01474, you will get this as equal to 5.47. So it's negative, so you'll write this as equal to negative 5.47, and that is the same value which you got over here also, the t value, the test statistic. The t value is, you get it as negative 5.47, and hence as this is a left tail test, so the probability that here you can see it has given the probability that it is greater than the absolute value of t. What that means is, this is slightly different. So here, suppose this is negative 5.47, negative 5.47. So this would be the modulus 5 point absolute value 5.47. So what's it trying to say is probability that t is less than 5.47, like, and greater than 5.47, negative 5.47 and greater than 5.47. This is the area. So this area is 0.00156. Okay, so for this is a two-tailed test. The probability p value is given, but we want the p value for only left tail test. That is, we want only this value. We want the p value that the t is the probability that t is less than t. So the t critical value of test statistic, whatever you want to call it. So here this would be equal to, see, this whole of it, these two would be equal by symmetry. These two would be equal. So this plus this is equal to 0.0156. So only one of them would be half. 156 divided by 2, because they are equal. So this would be half. We want only this area. So this plus this is 0.00. This plus this is 0.00156. We only want this, so that would be half of it. So calculating that, we would get it as equal to 0.00078. So that is what is our p value. The next pertinent question raised is, if alpha is 0.05, what is your conclusion? So our conclusion, you know that our conclusion will depend, like, if p is greater than alpha or if p is less than or equal to alpha. So our conclusion will depend upon these two ifs. So as you know, if p is greater than alpha, we do not reject the null hypothesis, and if p is less than alpha, we reject the null hypothesis. So that is the difference. In this case, as you can see, the p is 0.0078, and which is less than, in fact, the alpha value of how much, 0.05. So this is much less than 0.05. Hence we would go with the, if p is less than or equal to alpha, we reject the null hypothesis. So this would be our conclusion, that we are going to reject the null hypothesis. Okay, we'll reject the null hypothesis. What was the null hypothesis? This was the null hypothesis. So we are rejecting that b1 is equal to 0, and what would the interpretation would be, like, if we are rejecting the null hypothesis, we can say we have sufficient evidence to reject the null hypothesis and support the alternate hypothesis that the slope is beta1 is negative. This is our alternate hypothesis. So we would support the alternate hypothesis and reject the null hypothesis. We now have the C part with us, that just asks us to estimate the mean shear strength of, the age is given as 3.5 year old. So we just substitute that in the regression equation which we got from here. You can see this was the regression equation. So we just substitute that into our regression equation and get the final value. So y is equal to 5.057057 minus 0.08061 times 3.5 is the age given. So on calculating this, we would get the answer of shear strength, that is y is 4.77. That is the shear strength I am getting it as equal to 4.77. So that would be the simple answer for the part C. Let's move on to part D. Give the value of the coefficient of determination and briefly explain what it means in the context of this study. Coefficient of determination is nothing but the multiple r squared, this thing over here. Okay, I have underlined it. Okay. This thing over here. This thing. Multiple r squared, 0.8333. So I'll write that coefficient of determination, that is nothing but r squared, r squared, r square, and that is equal to how much? 0.833. Briefly explain what it means in the context of the study. I'll write the explanation. I've written the explanation. It means that it implies that, okay, you cannot see. Yeah. It implies that 83.3% of the variability in the dependent variable, like that is the y, here it is a shear strength, can be explained from the independent variable, that is the x, or in this case the age. So x can explain 83.3% of the variability in the shear strength in the y. That's what is the interpretation of this coefficient of determination r square term. This is just theory part. State the assumptions of the simple linear regression model. So here there are the four basic assumptions of linear regression model are given. It's clearly given. It's just the theory part. I will be further attaching you a more elaborate theory on how to detect the errors and all those things. And I guess your question asks about only one type of assumption, so I'll answer that here. This is the how to diagnose the normality. We generally do it using a normal quantile plot or probability plot. And this is done by the statistical software itself. I'll give you the theory in a Word file also. The question here asks you like what would you expect to observe if the assumptions were satisfied. If the assumptions were satisfied, then we can conclude that our linear regression model is perfect, that there is no flaw in our linear regression model. So our model is perfect. That's what we can assume. This simple linear regression model is without any flaw. It is perfect. That's what we